This is MSJ Chem, and in this video I'm going to look at enthalpies of solution and hydration. Let's start with a definition of enthalpy of solution. The enthalpy change of solution is the enthalpy change when 1 mole of an ionic substance dissolves in water to give a solution of infinite dilution. Next, we look at the definition of the enthalpy of hydration. The enthalpy of hydration is the enthalpy change when 1 mole of gaseous ions dissolve in water to give a solution of infinite dilution. Enthalpies of hydration are always negative, they are endothermic. Next, we look at dissolving. The first step is the solid ionic compound is broken down into its gaseous ions, that's the lattice enthalpy. In the next step, the gaseous ions are hydrated by water molecules, which is the enthalpy of hydration. Here we have a sodium ion being hydrated by these water molecules, where the negative dipole on the water molecule is attracted to the positive sodium ion. Here we have an enthalpy cycle. We can use the enthalpy cycle to calculate the enthalpy change of solution of an ionic compound. From the enthalpy cycle, we can see that the enthalpy change of solution is equal to the lattice enthalpy plus the enthalpy change of hydration. The databook values that you need can be found in Table 19, which are enthalpies of aqueous solutions, Table 20, which are enthalpies of hydration, and Table 18, which are lattice enthalpies. Let's try an example. Use the data in Tables 18 and 20 to calculate the enthalpy change of solution for sodium chloride. So from the enthalpy cycle, the enthalpy change of solution equals the lattice enthalpy plus the enthalpy change of hydration. The lattice enthalpy for sodium chloride is positive 790 kilojoules per mole. The enthalpy change of hydration for the sodium ion is negative 424 kilojoules per mole, and the enthalpy change of hydration for the chloride ion is negative 359 kilojoules per mole. That gives us an enthalpy change of solution for sodium chloride of positive 7 kilojoules per mole. In our next example, we'll use the data in tables 19 and 20 to calculate the lattice enthalpy for ammonium chloride. The enthalpy change of hydration of the ammonium ion is negative 307 kilojoules per mole. By rearranging the previous equation, we get lattice enthalpy equals the enthalpy change of solution minus the enthalpy change of hydration. The enthalpy change of solution of ammonium chloride is positive 14.78 kilojoules per mole. The enthalpy change of hydration for the ammonium ion is negative 307 kilojoules per mole, and the enthalpy change of hydration for the chloride ion is negative 359 kilojoules per mole. That gives us a value for the lattice enthalpy of ammonium chloride of positive 680 kilojoules per mole. And finally, we look at the factors that affect the enthalpy change of hydration. The size of the hydration enthalpy is determined by the attraction between the ions and the water molecules. The first factor is the size of the ion. The smaller the ion, the stronger the attraction and the higher the enthalpy change of hydration. The second factor is the charge on the ion. The higher the charge on the ion, the stronger the attraction and the higher the enthalpy change of hydration. That's all for this video. Don't forget to check the video description for a link to the practice worksheet.